This is the activity on rotational symmetry. The objective of this activity is to understand the rotational symmetry by identifying the order, which is a very important word in rotational symmetry, the order of rotational symmetry in various shapes and patterns. So we can use different shapes or different patterns to conduct this activity. Now let's understand the concept behind this particular activity. So what do you mean by rotational symmetry? For that, let's take the example of a square. Now, if I place the square horizontally like this and I give it a 90-degree turn, what will happen to the square? The square will look like this, which is exactly a replica of the original square. So how many times can you turn this square to get the original square? You can turn it 4 times, and therefore this number 4, how many times you can turn the square to get the original shape is 4, and so this number 4 is known as the order of rotational symmetry for a square. Can you guess how many times can you turn a rectangle or rotate a rectangle to get the original shape? Now the 90-degree criteria is not going to work. If you rotate this through 90 degree, you will get a rectangle which is like this, and this does not resemble the original shape. So you have to turn it by 180 degree and then by another 180 degree, that means 360 degree, to get back the original shape. And so the order of symmetry in case of a rectangle is 2. The important part and the interesting part is that of a circle. You rotate a circle even 0.1 degree, it will give you the same shape. So how many angles can you find out for which you get the same shape as the original? They are infinite angles. And so the order of rotational symmetry for a circle is infinite. Likewise, if you have a regular figure like a triangle having all the 3 sides equal, or an equilateral triangle, then the order of rotational symmetry will be 3. That means you have to rotate it by 120 degree to get the same shape. So we can go on and on. You can have the shape of stars, which we will be taking up in this activity to find out what is the order of symmetry. Let's now understand the material required to perform the activity. So we require, the first thing is the printed or drawn geometric shapes. It can be square, rectangle, circle, star, etc. You need tracing paper, you need pencil or marker, you need push pins which will act as the point through which the object will be rotated, and you need a protractor. So let's now perform this activity and understand the properties of rotational symmetry. So to perform this activity on rotational symmetry and to find the angle of rotation, the first figure I am taking up is a square. So you can pin this square across its center. Like in the center of the square, you have to put a pin, and then this square will be free to rotate like this, right? Now this is the initial shape of the square. So I'll write a square here. Now to find the order of rotational symmetry, you have to keep on rotating this square across the pin. So this part is fixed and it will rotate like this, and after a rotation of 90 degree, the square regains its shape. So one rotation, the original side was here, this was the original side, now it has become vertical. Then if you rotate it one more time, it will become square again, but the original side which was at the base is at the top now. Then across the pin you rotate it once more, an angle of 90 degree, the side comes here and the original shape of square is regained. And one more time, the final time, if you rotate this, you will get the original shape of a square. So you saw that you are rotating through an angle of 90 degree. Or how many times have you rotated this figure? You rotated it 4 times to get back to the base at the as the horizontal side. So 4 times rotations, and therefore the order of symmetry, the rotational symmetry for this square is 4. Now to find the angle of rotation, you just have to divide 360 by the order 4, you will get the angle. So that verifies, see, we rotated this through an angle of 90 degree to get back the shape, and therefore this completes the rotational symmetry for square. Likewise, if you have a rectangle, now this is the original shape of the rectangle, so you can pin it at the center and mark the base. So this is the base, right? I have marked it here. Now if I rotate it 90 degree, what is going to happen? This rectangle is going to lose shape. Now this was not the original shape of the rectangle. So 90 degree is not the angle of rotation. I have to rotate it further 90 degree to get the original shape. The rectangle regains its shape and the side which was at the base is now at the top. So after a rotation of 180 degree, I got the original shape. Another rotation of 90 doesn't get me the original shape, and another rotation of 90 gets me the original shape again. So in case of a rectangle, the order of rotational symmetry is 2. Why? Because this shape was attained 2 times on complete rotation of 360 degree. So if you divide 360 by 2, you will get the angle of rotation in case of a rectangle, that is 180 degree. Likewise, if you have the third figure, which is an equilateral triangle. So you can pin this equilateral triangle now across the center and write in the observation table equilateral triangle. Now what's going to happen here is, you want to gain the same shape again after rotation, right? Now this is the base. Now if I rotate it, I keep on rotating it, I should have a base, right? So keep on rotating it and I get the shape here. See, it regains the shape of an equilateral triangle. So this was at the base, now it is here, so I can rotate it further. So I got the same shape once, rotate it further, you get the base again. So we have got the same shape twice, and finally come back to the original shape. Rotation is done 3 times now, and we have got to the original shape. So 3 times rotation, and so the angle of rotation in this case will be 360 divided by 3, that is 120 degree is the angle of rotation in case of a equilateral triangle. Likewise, this is the interesting part. Here we have a circle. So if you fix the circle here at this point using a thumb pin, then if you rotate it even 1 degree or 10 degree or 45 degree, the same shape is going to be there. So the circle will never lose its shape, and therefore for a circle the order of rotational symmetry is infinite, because every angle will give you the same shape, and therefore angle of rotation cannot be written in terms of any particular value. So likewise, we can have another figure here, which is a 5 vertex star. Now if you see a star here, if you fix it like this, using this point, you can fix the thumb pin. Now let's assume that this was the original shape, right? So we have this at the base. So once this point comes at the base, it will regain its original shape, right? So let's keep on rotating now. If I rotate it like this, I have another vertex here. So 1, rotate it further. This is another vertex here. 2, same shape. Another rotation. Another vertex here, same shape again. So 3, further rotation. Another vertex here. So 4. And finally, another rotation which gets me the same vertex which was originally there, and therefore after 5 rotations the star regains its original shape, and during that time in rotation of 360 degree I had to turn it 5 times to get the same shape. So what is the angle of rotation? 360 divided by 5, which is, this is 72 degree as the angle of rotation. And that completes our activity on rotational symmetry.